This is abstract data type and problem solving for graph and its applications. Okay, so today our agenda are gonna teach you about a graph, terminologies, breadth first search. Okay, for graph, what you guys need to know is some words, some like terminologies that you guys need to know. The component of the graph have vertex and edge. So vertex will represent as V and edge as G. So this will be the set of the vertex and set of edge. Okay, so this and G's will represent of the graph, and graph means that it will be consist of vertex and edge. Okay, as the representation component. So let's learn some words about graph that you guys need to know. One is indirect. Second is direct graph. Indirect means that they can go back and forth. So it's become like bidirections. They can go like forward or backward like this one. So there is no arrow at this. So you can travel from V1 to V2, V2 to V3 with no direction forced. But for the direct graph, at the edge, they're gonna have the direction that will try to force you to go to just a direction that you can go. So it will be just one direction that you can follow. Cannot go back and forth like an indirect graph. Okay, so this is 4 things that you need to know on this page. One is the vertex, which is the node, right? And then second one is the edge. Okay, second one is the edge, which is this one will represent the graph, V and E. Okay, and another two is indirect and direct graph. Indirect means you can go back and forth between the edge among the node, right? Direct one is you have to follow the directions that 8 will point to. So here in example how we can define a graph. So in this page we have graph 1, graph 2 and graph T. So you can see from the symbol, can you tell me that where is the direct and indirect graph? Direct graph is this one, right? So they provide a direction and this one is no direction. So by direction can go back and forth. And you can see that 3 is also a set of the graph as well. Okay. For graph, two more things that we're gonna learn on this page is complete graph and incomplete graph. Okay. So actually, if you look at this one, this side is the complete graph. So you can see that every single node or every single vertex will have the edge connected equally as three edge connected to each vertex, right? But if this is incomplete graph, how many edge? One in, one out, one in, two out, right? This is 1 and 2, 1 in and 2 out, and this is 1 in, so it's not complete. So this is 2, this is 3, and this is 3. It is just 1, 1, 1 and 1. So it's not complete. So it's will call like an incomplete graph. But this one will be the complete one that every single vertex is a singular, vertex is a plural one. So every single vertex, they will have exactly the same number of the connection by edge. And how we can represent this kind of graph. So if it is unidirectional, means that there is no direction. So we can use a set like this. But if it is a direction, they have the direction like this. So we need to use this symbol to represent. Okay, and another one is we will have the formula for the edge calculation, like for the complete and then incomplete and the like graph. So this one is for the complete. Okay, complete and direct, what does it mean? Leave this one, right? So it will be n n minus 1 divided by 2. So n is 4, n minus 1 is 3, and then is divided by 2. So is how many? 6, right? Okay, let's count. 1, 2, 3, 4, 5, 6. Yeah. But if we have a direction, if we have the direction, so it means that they cannot go back and forth, then the number is will be like n, no, not divided by 2, means that you need to have another line for going back and forth like this, come in and come out like this. So this will be equal to 12 line. Got it? So this is just a symbol. So last time you learned indirect, direct, okay, and learned complete and incomplete. So this is the terminologies that you guys need to know for the graph and how we call it. All right. Here is showing the application of the graph in the reality, just for the electronic circuit, that we will set something as a node, and then we're gonna have the resistor, capacitor, inductors as a resistance that like a buffer or some resistance between each node. So it will be like a weight for each node to connect it all of this circuit together. So we can learn how the electricity flow through this circuit, how it flow, and like current or velocity. Yeah, we can use this as a representation by using graph for the electronic circuit. And also in like your Google map or some connection network in the map or somewhere else, we can also use the graph to represent the road or the air freight, or some like transportation by train, whatever, by bus or by car, that you can represent the way or the route, how the pathway, how we can connect to each city or state. And another terminology that you guys need to know is the adjacent and incident. Okay, for the adjacent and incident, remember that adjacent we will talk about the vertex, okay, and incident we'll talk about to edge. Okay, so let's see some example. Here is another one that we need to know about the vertex, which is the degree, that I think you guys already knows it, like in degree and out degree, right, at each vertex. So in the direct and indirect graph, then we can count the degree here. So if this is the direct graph, then we have in and out, and if an indirect graph, then we have just a connection of the degree. Okay. Let's see the example. So here is the example of the degree. So here is at each vertex, the degrees will be equal to 3. But for this graph, it is 2, this is 3, and this is 1, right? And when it is when it's a direct graph, then you need to define in and out. Okay, you need to define in and out for the degree. Another one that we will learn is the part, which like the pathway that we can like pass through each node, we call as the part. Then we will connect the edge by the part. Okay, so if we see this line, so you can see how it's travel, and they will have more than one version of travel if they have some cycle like this. Okay, like we can connect A, B, E, D, C, or you can connect from A, B, E, C, D. So if we have a cycle, then it means that we have some like more choice to select. And the next one is like this, we have the just one line, no cycle, then it's just only one choice that is can follow by B, E, D, C or C, D, E, B, one way. Cannot like have a choice like this. So as I told you, when we have a cycle, then it will represent something, okay, that in when we see the cycle in the graph means that there is more choice and more possibility to go, okay, like from A you can better go left or go right, but by the way you will get the get through the solutions, even you're gonna go to C or you're gonna want to go to D, right? So this will be called like a cycle that is well connected to each other. The terminologies they explain that is mean that the last vertex is the same as the first vertex. So the last and the first is the same position. So it's, for example, they start from C, C to A to D, and then D to C. So it's come back like a circle, then become the cycle. Simple part, so is the condition is no repeat vertex. So just like go through without repeated, so it's not a cycle at all, right? So this is the terminology for the simple part and cycle. And another one is the connect graph. This one is quite easy. So this is connect, mean all node is connect, but here is not connect, just that. Subgraph mean like when we have for connections and somehow they will have like small graph here, and it will like calling as a subgraph of the set it, and they were going to have a group of the connected component. Okay, so this page we have connect graph and subgraph. No. Okay, here is represent the subgraph of the graph. So let's look at this one. The upper part. Complete graph. The subgraph can be just one node, or just connect by half, like upper half, lower half, or just connect by some part. Okay, so it's called like a subpart, like a subset of this complete graph. Same here. This also the subgraph of this one. So it can be all possible cases that we can have. Okay. And another one is the formula that we calculated for the connectivities. If we know the number of the vertices and if we know the number of edges, then we can calculate it, checking that the graph is complete or not complete by calculate from M and N. So just very easy. N is vertex, then how many of this? 1, 2, 3, 4, 5, then N is 5. M is edges, so this will be how many of this? 1, 2, 3, 4. The formula is using N and N minus 1 divided by 2, right? To get M, if you still remember. So what we get, we have 5, right? Multiplied by 4 and divided by 2 is equal to 10. Then it's showing that if the graph is not complete, then M supposed to less than this number, but actually it's not. Okay. Same thing, so we can also use M and N to calculate in this one how many of M and how many of N that we have, and then we can like checking that if M is less than N minus 1, G is not connected. So this is how we can check the connectivities. Okay. Direct graph. So here is the direct graph. Then you can see that they have a direction. And here is the operation that we can do for the graph in ADT. One is we can create it, we can insert the vertex, we can insert the edge, we can delete the vertex, delete the edge, check that is empty or not, return true and false, and then get the list of adjacent. Okay, so let's talk about the adjacent first. There is two things. One is the adjacency matrix and adjacency list. Okay, let's talk about the adjacency matrix. So we would like to talk about the adjacency matrix, mean that we try to represent the graph as a matrix. Okay, we try to draw the graph by using matrix, and then we will access the value of I and j in the matrix by using this precision I and j for in the adjacency matrix. Let's see the example. So here is the complete graph, and then this will be the connection between each node. For example, this is node 0, node 1, node 2, node 3. Then this is form, right? It is 2. Form node 0 to node 0. Node 0 to node 0, there is no feedback loop like this, then it becomes 0. From node 0 to node 1, yeah, they have the edge. So this one will represent the edge, no? From node 0, this one, right? From node 0 to node 2, yeah, we have the edge. From node 0 to node 3, and we have the edge here. So we can fill in this line. And how we can check that it's symmetry or asymmetry. So along the diagonal, we can see that this part and this part, if it is exactly the same, means that it is a symmetry. So what does this mean if it's symmetric? Means that the indirect graph will be the symmetric one, but for the direct graph will be asymmetric, okay, like this one. So if you look at the triangle, and then the left and the right here is not exactly the same, means that when you see this condition, it means that it is the direct graph, and this is the indirect graph, these two. Okay, and this is how we calculate the degree of the direct and indirect graph. Then we need to define it, and this is how we create the adjacency list, create the node by using the node as a representative. Like this one, we start from 0, and you know that 0 will connect to node 1, 2, 3, then we connect to 1, 2, 3, node 1 connect to node 0, 2, 3, so connect to 0, 2, 3. Node 2 connect to 0, 1, 3, 0, 1, 3, right? For this graph, okay, node 0, 0 connect to what? 1 and 2, right? So connect to 1 and 2, this line, 1 and 2. Node 1 connect to what? 0 and 3, so 0 and 3, right? Node 2 connect to what? 0 and 3, so 0 and 3. Node 3 connect to what? 1 and 2, right? Node 4 connect to what? To 5. 5 connect to 4 and 6. 6 connect to 5 and 7. 6 connect to 5 and 7, and 7 connect to 6. So this is how we can draw the adjacency list by using the node, and then use the link. And if it's a direct graph, also very simple when doing the same thing. Like when 2 is not connected to anyone, then there is nothing connected to. And node 1 connect to 0 and 1, right? Node 1 connect to 0 and connect to 2, right? Connect to 0 and connect to 2. And node 0 connect to 1, this line. Okay, so now you can get the list